In this unit, we're going to talk about user and system interfaces. So information systems have to interact with both people and other systems. So people being the users and other systems being our system's interfaces. A poorly designed user interface can make the information system almost unusable. So it's very important that we design systems that have an efficient and well-designed user interface that makes it easy for people to interact with our system. If people find it difficult to interact with the system, no matter how hard we try to make a really powerful, great system with all the business rules captured and powerful databases with all the normalization, all this stuff that we're going to talk about, if we fail to have a good user interface, people won't use it, our system will not be successful. And also, poorly designed system interfaces can be a source of errors and inefficiency. So if you don't have a good user interface, it can end up costing the organization money to train people how to use it, or it might take a long time to do certain tasks that maybe it could have been a lot faster if you had a good or well-designed user interface. So user interfaces, for both the user and the system, you have both inputs and outputs, and we're going to talk about both the inputs and the outputs. And it's good to think about those two areas when we talk about user and system interfaces, to kind of divide it into input and output. And we'll talk about them throughout this unit. We'll look at both. So the user interface is the inputs and outputs that directly involve a human user, typically our actor in our diagrams that we've been doing before. When we did those the use case models, we talk about an actor, and that's usually the person who's interacting with the system. And remember, an actor doesn't have to be a person, it could also be a system. So a dialogue goes on between the actor and the system, which we're going to talk about, and how to think about those dialogues. A system interface, on the other hand, is the inputs and outputs that require minimal human intervention. So these are inputs that are typically captured automatically, and outputs direct to other systems, printed and distributed outputs such as statements and reports and printouts and things like that. So our textbook talks about this concept of user-centered design. That's a design technique that embodies the view that the user interface is the system to the user. And this really dates back to, no surprise here, back to the 1980s with Apple. Apple really kind of started this whole trend of powerful and sleek user interfaces, and this concept that a well-designed user interface can make or break your product. And that really drove the principles of user-centered design. So it focuses early on users and how the users use the system. So we design around how the users are going to interact with the system. And that was really, if you think about it, why we did those use case diagrams. That really helped us brainstorm how the user is going to use the system. So it evaluates designs to ensure that you have a very high level of usability, and we'll talk more about usability in a little bit. And we use iterative development, of course, so that we're letting users test the system, making sure that the user interface works with the system. And it's important to note that, in years past, a long time ago in systems analysis and design, user interfaces were kind of a second thought. But in contemporary analysis and design, user interfaces are very important, and we talk a lot about user interfaces. I think, the industry as a whole has kind of come around to this idea that user interfaces are extremely important. So let's talk about some user interface design concepts. I keep using this term human-computer interaction. What exactly is that? Well, it's a field of study that's concerned with the efficiency and effectiveness of user interaction with computer systems. So human-oriented input and output technologies, the psychological aspects of user interfaces, all of these things are studied in human-computer interaction. You can actually take whole courses about human-computer interaction. So it's a pretty big field. And one of the things that field talks about is visibility and affordance. And these are the sort of easy concepts for us to talk about in systems analysis and design. There are, of course, lots of other things and other concerns that human-computer interaction talks about, but we'll focus on visibility and affordance. And really, these are fancy ways to say that to be usable, a control must be visible to the user, and its appearance suggests its functionality. And you can probably think of examples of things like this, like the controls in a media player that look like a physical tape recorder, or with buttons and scroll bars. All those things are examples of visibility and affordance. It's pretty obvious that a scroll bar allows you to scroll up and down because you've got the arrows on the top and the bottom, and you've got that little box that shows you where you are in the document. You can click and drag it to go through the document. So all of that is about visibility and affordance, and are examples of that. So there are three components that you have to think about for the user interface. The first is the physical aspects. So the things like the desk, the chair, the keyboard, touchscreen, keypad, all of the physical things that we have to worry about for a user interface. And why do we care about those things? Because we have to design around those physical aspects. And I'll talk more about that in a little bit. We have perceptual aspects, things like colors, shapes, textures, fonts, sounds, menus, and buttons. And then finally, conceptual aspects, which are things like our customers, order shipments, feedback, all the things that are conceptual that we have to understand for our user interface and that we have to convey to the user. So there's also this concept in HCI of metaphors. And a metaphor, so there's a couple different kinds of metaphors. I'll talk about those first. We have a direct manipulation metaphor is where an object on a display is manipulated to look like a physical object. And you've probably seen examples of this. For example, a recycling bin, or what used to be the trash can in the old days on your desktop. That is a metaphor for throwing something away, right? It's not actually a recycling bin, when you put something in the recycling bin on your computer, but most people understand because it's a recycling bin that metaphor helps people understand what exactly that's for. And that's a pretty obvious example, but there are lots of other examples. And speaking of, the recycling bin being on the desktop is a metaphor itself. And if you think about it, think about a real desktop. You've got, a big empty area in the center and things that you can work with that are around that. And when you need something that you're going to work with, you move it to the middle of the desktop to work with that. Although most of us nowadays, on our desktop, the only thing we have is a computer, which itself has a desktop. But back in the old days, if you just had a desk, you might have a pad of paper on one side, a calculator on the other side, some pen and paper, maybe a calendar, and whichever thing you're working with, you would move it to the center of the desk to work with that. And that's the idea behind a desktop metaphor. And this has really become the de facto standard in desktop, or we could even call it a desktop, right? In workstation computers. The document metaphor is the metaphor in which data is visually represented as papers, pages, and forms. So documents themselves take on that sort of physical appearance that a standard document would have. And some of you may remember in the old days, a long time ago, word processors did not show didn't look like a piece of paper. They didn't look like the document that you were going to print out. And that was a major change in word processors when they started to look like what you were going to print out. But back in the old days, it was just text. And you would have code that would show you the formatting, but it didn't actually appear bold on the screen. And you didn't see you might see a symbol that would tell you that there's a paragraph break or a page break, but it didn't actually show you that. And then eventually somebody came along and made it so that you could actually see all that stuff, and that certainly enhanced the usability of things like word processors. The dialogue metaphor is a metaphor in which the user and the computer accomplish a task by engaging in a conversation. So the idea here is that that the user is going to engage in some kind of conversation with the computer to complete a task. And sometimes you can think about that conversation to design the user interface. And we'll talk more about that later on, and we'll see an example of that. So here's a table that's from the textbook that we use in this course. And you can see here we've got our metaphor. So direct manipulation example, a user drags a folder icon to an image of a recycling bin, which we talked about. You've got the desktop metaphor, which is the computer startup, Windows user sees a desktop with the icons for the clock, the calendar, and so forth. The document metaphor, the dialogue metaphor, and so forth. So you can take a look at this in your book, and you can see some examples of that, and this gives you a little bit more of a in-depth description on some of these things. So some guidelines for developing a user interface. First, design for consistency. So consistency is pretty important. I'll show you an example. This is actually my brother's webpage. He has a small business, and if you look at this webpage, it looks okay. It doesn't look great, but it kind of gets the job done. But the problem with this webpage, take a look what happens when I click this pricing button. Notice what happened. That becomes a home button. And now my home button becomes pricing. Each time I click on one of these menu items, everything changes. So the user can't consistently go to the same place to get to the same thing. And in the real world, we're used to that. We're used to, okay, if anytime I go to the left side of the page, that means I'm going home. So the next time you go to the left side of the page, you think you're going home, but really you're going to the pricing information. So that's an example of of inconsistent design. And so it's a good idea when you do design to try to stay consistent. So let's go back to the presentation. So we want to design for consistency, provide shortcuts when necessary, provide feedback to the user so they know what's going on. So if the user is waiting for something, we should tell the user that they're waiting for something. Dialogue should yield some kind of closure, so they should know that they've completed their task. Error handling that provides some kind of guidance. So if something went wrong, it should tell the user why it went wrong, how it went wrong. Usually want to try to avoid codes and things like that. Error number 45. That's not very useful, but you could do something in plain English that tells the user what happened. Easy reversal of action. So if they did something they didn't mean to, they should be able to go back to make a change. If you prevent people from going back, that can cause some issues. And you want to reduce short-term memory load. People can't remember a lot of things, so you want to make sure that you design your system in a way that people don't have to constantly remember what they've done or keep track of all the things that they've done. So some kind of visual cues that help people. One of the classic examples of short-term memory load is when the phone company was coming up with the idea of telephone numbers. And in the old days, the telephone company had this idea that we are all too stupid to remember phone numbers that are longer than 5 digits. So they needed a 7-digit phone number, so they decided to use the first 2 digits would be letters instead of numbers, and that those letters could mean something. So, for example, when I was a kid, my phone number was Olive42097. So OL42097 would have been my phone number. But as we all know, most people are capable of remembering 7-digit numbers, but the phone company didn't know that back in those days. The whole idea of a phone number was a new concept. So they thought, well, we'll reduce this need for short-term memory by designing the system of numbers so that people can use letters and numbers, and they put letters on the keypad so that you could use the letters instead of the numbers and remember words. So that's a good example of that. So when we're going to design the menu hierarchy, which your book talks about, your book is going to discuss menu hierarchy. It's an important part of the user interface design, designing these menus. One technique to do that is to use your use cases. So your use cases can help you define what your menus are going to look like in your system. So we can design our user interface use case by use case, and our menu hierarchy use case by use case. The menus are a typical way to organize access and use case functionality. Different types of users can have different menus. So an administrator might have one menu, a regular user might have a different menu, a customer could have a different menu, so lots of different types of menus. They're useful to design an overall menu hierarchy and then subsets of different users. Once the hierarchy is established, menus can be implemented in a variety of ways. And one of those things that we use to develop user interfaces as well that I talked about earlier is this idea of dialogue design. So for each use case that we have to think of some natural flow of a dialogue between the user and the computer. So you have to kind of imagine if this user were interacting with a person rather than a computer, what's the conversation that would happen to complete that task? So based on the flow of activities in the use case description or the system sequence diagram, we can develop this the dialogue. You can use natural language to emphasize feedback to the user, and you can create a storyboard of the dialogue showing the sequence of sketches of the screen in each step of the dialogue or storyboarding. So I'll show you an example of that in just a moment. Important when you're designing these dialogues is to review that storyboard with your users and try to give them a way to experience that so they can give you feedback on whether you think that's going to work or if that's not going to work. Remember, it's always easier to make these changes before you commit code into the system as opposed to prior when you're still doing the design. So from dialogue to storyboard, so here's what a dialogue might look like. What would you like to do? This is the system on the right-hand side saying, what would you like to do? The user on the left says, I'd like to check out. And then our system says, very well, what is your email or account number? And the user says, well, my email address is emmanuelgoldstein@gmail.com. Then the system says, are you Emmanuel Goldstein at 101 Sassafras Street? Because the system at this point would have looked up that customer. And he says, yep, that's me. And then the system says, I have all the items in your cart in stock, and since your order is over $100, I can ship the item for free. You could also pay $20 for 2-day, $35 for next day, $11.50 for USPS. Which would you prefer? So this is the example of the dialogue that's taking place between the user and the system. We could take this dialogue that we have brainstormed and we can storyboard this into user interface. So this is an example from the RMO case that we talk about in the textbook. So you can see here the user clicks on checkout. The system asks for their email address, And then the system says, is this who you are? And the user says, yep, that's me. And then they tell it what kind of shipping they want to use. And then we can expand on that. So the user might say, yeah, I'd like to use free UPS ground shipping. The system's going to ask, do you want to use that shipping address, and so forth and so on. And then that dialogue would look like this. So we would storyboard it, as you can see here. So that's what the actual system could look like. And you can see that we've developed that storyboard from the dialogue that we brainstormed that would make sense for the interaction between the user and the system. So some guidelines for Windows and Forms. So first, interface layout and formatting. We want to have consistency. We need labels and headings so people know what everything is. Distribution and order, fonts and colors. For data entry, you want text box, list box, combo box, radio buttons, check boxes. These are all standard controls in most user interfaces. So when you're designing the windows and the forms, these are generally the types of controls that you have access to that developers can easily implement. It's a good idea, too, I should mention before I move on, that that designers can come up with all kinds of crazy ways for people to interact with the system, but in the interest of rapid development, it's a good idea to stick with what people know, right? For a number of reasons. Number one, almost everybody knows the concept of a text box, a list box, a combo box, radio buttons, and check boxes. It's all over the web. It's on most user interfaces in Windows and Mac. Now, you could come up with new ways to do that, but then number one, people are not going to be familiar with how to use it. And number two, most of the toolkits that developers use are not going to include these custom user interfaces. But that said, the only way we come up with new concepts and new designs that work well is for people to push that envelope. But you have to decide in your system whether it's appropriate to do that or not. So navigation and support controls, most of you are probably familiar with the idea of minimizing and maximizing windows, closing windows, using scroll bars, and being able to resize. I can't tell you how many times I've worked on systems where they've made it so that you can't resize the window because the developers just thought it would be easier to design it that way. And then a user goes to use the system on a system with a small screen, and you can't resize the window, and you can't see half of the input boxes. So, it's important to include all this functionality to give you a little bit of flexibility on for the environment and the type of computer they're going to be using, etc. So, some guidelines for web browser user interfaces. As I showed you before, consistency is really important. And one way you can handle consistency is cascading style sheets. So in web development, cascading style sheets can be applied to a web page, which will force the browser to use the same type or the same font, the same size fonts. The color scheme is all going to be the same. So you can kind of unify all of the user interface design properties with the cascading style sheet. So most modern websites and web pages use cascading style sheets. And the nice thing about a cascading style sheet, if you decide to make a change, so let's say somebody says, you know what, we don't want to use gray for the background color for the whole website anymore. Now we want to use light brown. You can make one change in the style sheet, and the entire site changes to light brown for the background. So it makes it easy to make changes like that. So lots of good reasons to use cascading style sheets, and that certainly helps us with consistency. Some performance considerations. We have to be sensitive to the network connection, the amount of information that's going to be transmitted, the type of information that's going to be transmitted, pictures, video, and sound. Pictures, video, and sound can be powerful, but a couple things. Number one, you've got compatibility issues. Not all systems will be able to support all types of pictures, video, and sound, and sometimes you just don't need it. I worked with a group in New York that had a system that manages their entire business, and one of the things that they looked at when they were replacing the system is some of the vendors had pretty pictures and sound and all kinds of extra fluff in there to make it look nice and look pretty. But the only people that would be using this system were employees of the company, and all that extra stuff added a lot of bandwidth and a lot of processing resources. And when you multiply that times 950 people that are going to be using the system simultaneously, it increased the requirements on the servers and the network to the point where it didn't really make much sense to have all that stuff. So they ended up going back to vendors and saying, hey, you guys need to pull all this stuff out. We don't need it, for one thing. And number two, it adds a lot of overhead where we don't need it. It's money we have to spend that we don't need to spend. So sometimes you just don't need that fancy stuff. You also have to think about users with disabilities, even on the web. So you have assistive technologies such as software with text-to-speech and voice recognition. that adapts user interfaces to the special needs of the persons with disabilities. Think about somebody who is blind who's using your website. A blind person using your website is going to hear a dictation of the things that are on the screen. And if you have a lot of written text that doesn't need to be there, they're going to have to sit there and listen to all that text before it gets to the important stuff. So certainly something to be aware of and something to design for. I think too often developers forget about people with disabilities, and it's important to remember that stuff. So some guidelines for handheld devices, and handheld devices can be a bit of a challenge. One challenge is they have very small screens. They have small keyboards, so you want to limit the amount of typing that people have to do. They usually have touch screens, although nowadays it seems like everything has a touch screen. They may not have unlimited network capacity, so you have to worry about how much network chatter there is. So certainly a lot of challenges, and this is an example of maybe what the RMO website that we've been talking about throughout the semester might look like if it were on a mobile device. So this would be just kind of an alternative design that would work on mobile devices. All right, so system interfaces. The system interfaces we talked about, so we've kind of concluded the user interface. Now we're going to talk about the system interface, which is interfaces to the system from other systems. So, like I've talked about several times before, most modern systems don't just interface with people, but they also interface with other systems. So we have to think about that in the design, and we have to figure out how we're going to handle that in our design. And lots of different ways to do interaction with other systems. So inputs from and outputs to other systems, they're direct interfaces with other information systems, normally formatted as network messages. There's lots of different ways to do that. There are highly automated inputs and outputs, which are captured by devices such as scanners, or generated by people who start a process that proceeds without further human intervention. And then you've got inputs and outputs to external databases, which can supply input or accept output from the system. So lots of different ways we can, or other systems that we might have to interact with. So you've got external databases that you might have to interact with. You could have automated inputs from things like scanners. You could have external systems that send messages to our system. Some kind of interactive data entry. You can have messages that we have to send to other external systems. All kinds of different things. So what is a web service? So this is all the rage now. Everybody's using web services now to do integration. If you think about back in the old days, the way we did integration were things like, and our book doesn't really talk about this too much, but there were standards like EDI or ANSI X12, and these were all text-based standards where you would literally generate a text file that was delimited with carets or pipes or commas or whatever, asterisks or some symbol would delimit different fields in the file. And you would create this file and send it to another system, and the other system would read that text file, and it would just usually you'd have some specification that would tell you, that the third position on the fourth line is the customer name, and the fourth position on the second line is the customer's ID number and the date of birth or something like that. So all that stuff would be specified, and everyone would exchange all these different specs, and there were standards for these specs. I work in healthcare, and HL7 is one of those specifications where we have these sort of delimited files that get tossed around networks. So, and that worked. It works pretty well, but it's not very flexible. Everybody has to know what the spec is. So later on, somebody came up with this idea for XML, and JSON also is kind of similar to XML. Our book doesn't talk about JSON too much, but XML is the extensible markup language, which is a series of tags that can describe something. So, and you can see my example here, name and then /name. Everything between those two tags would be the person's name. So it's not only, instead of being delimited by some character, the file is described. There's metadata that describes what the data is. So it's a lot more powerful than just simple text files. And the neat thing about XML too is that you can dynamically transform XML using things like XSLT, which can facilitate integration between different systems. So if I'm using an XML document to represent my customer and their order, and somebody else that uses XML to represent a customer and their order, we could create an XSLT that can translate between our two different formats for that XML dynamically. And that way, all the code within our system doesn't have to know about the standard on some other system. We can use the XSLT to figure that out and dynamically change that stuff. So lots of cool stuff going on with XML and XSLT and web services. And you might hear the term SOAP, or Service-Oriented Architecture Protocol. And that's an example of an XML web service. So this idea is that the idea behind SOAP is that you can post information between different web services. I'll give you an example. So let's say you're, well, even better, perhaps I can show you an example. So here's a simple example of a form that I whipped up real quick. I put this video on pause for you and threw something together. So let's say this was a contact form for a web page. So normally I would just fill out my name. So maybe it's last name, first name, and then I submit the form. And most of us, when we do this, we hit the button to submit the form, and something happens. It takes us to another page, says thank you for filling out the form, and we forget about it. But what happens under the hood? So let me fill this out again. This time I'll put Brian Green, and I'm going to turn on debug mode. So when I hit send form, now it's showing me that I have a server that's actually processing this form. So you can see here, the first field was Brian, the second field was Green. My web address was brian.green@gmail.com. That's where it's emailing the response from that form, and so forth and so on. And down here, I'm kind of showing all the form variables. So, when you fill out a form, something happens. The server, when you fill out a form on a web page, it's submitting that information to a web server and then showing you some information, showing you some kind of response. And what's interesting is, at some point, somebody came along and said, you know what, we could do something more interesting with a form. What if we could use forms to interact with different systems? So take a look at this example. This is from W3 Schools. So down here, this is an actual XML document. So what if I, instead of just posting, basic information, what if instead I post an XML document? In this case, I'm posting this XML document. This is defined for me somewhere. Usually it's called a WSDL, but another class could teach you all about SOAP and SOA and so forth. But I'm going to submit a temperature in Celsius, and the type of value I'm submitting is a string, so that's the data type. So let's say I put in 0 degrees Celsius. I'm going to hit invoke. Now what invoke's going to do is it's going to take this value, it's going to stuff it right here and take this whole thing and submit it to the web server. And then that web server is going to send me a response in the web browser. So the browser is going to show me a response, and that response is going to be yet another XML document that's going to show me the temperature in Fahrenheit. And I could then consume that with some application. I could consume XML to use that result. Now, this is a simple example. I'm only submitting one thing and getting back one result. But this could also be very complicated. I could submit all kinds of information in my post to the web server and get back a whole data set that I have to parse out, which is why XML is nice, because it's very easy for computer systems to parse out XML because the data is all described with this metadata. A computer can easily discern that this is the Celsius to Fahrenheit result, and it'll give us the answer. So let's hit invoke. That's going to go call some web service, and then if you take a look, I get back an XML document. Let's take a look at that. I'll view the source. Well, I guess you can see the source right there too, but it sends me back XML, and you can see the answer is 32. So, which we know is the case. So I submitted 0 for Celsius, and it gave me back 32 for Fahrenheit. So that web service worked. So you can take a look at something like this. And web services are kind of neat. There's lots of neat things you can do with web services. And again, that was just a very simple example. But that is a great way to integrate different systems. So obviously, web services are pretty important concept to understand. And I may post another video that shows you some examples of web services. So an XML is posted to a web server, and then you get an XML response in the browser that gives you the response to whatever it is that you posted. REST, or representational state transfer, is where you pass parameters in a URL and get a response from the server. And let me see if I can whip up a little example for you for REST. So I'm sure all of you are familiar with Google. Normally with Google, you would go to google.com and you would type in some kind of search term and you would get a list of results. But in theory, you could do the search right in the URL. So I can pass parameters in the URL. You can see here, I pass the Q parameter. So question mark means it's a list of parameters. So I'm going to pass the Q parameter, and the value of the Q parameter is dolphin pound Q equals dolphin. And I could put any term I want there. We'll try dolphin first. So if I put dolphin there, notice it gives me the search results for dolphin. I didn't type it into the form. I just put it right up here as a parameter. And we could try something else. So let me put whale this time. So I'll do whale. And there we go. We get search results for whales. So this is the basic concept of REST. And you might hear people talk about RESTful web services. That's when they're talking about being able to pass parameters to a web server by simply using the URL. It's a lot more complicated than that. I don't want to really oversimplify REST, but again, REST is an important concept to understand for systems integration. So SOAP and REST are two really great ways to do systems integration. They're very flexible. A lot of systems support this stuff now. You'll hear about APIs. I think I'll talk about APIs later on in the course as well. And a lot of APIs are SOAP and REST. All right, so let's continue. Oh, by the way, this is an example of an XML. This is a much larger XML document than we looked at in that little Fahrenheit Celsius example, but this is from your textbook. But you can certainly find, there's no shortage of examples of XML out on the web that you can certainly take a look at. So legacy integration standards, like I talked about, were things usually where we use text files. And in order to get a text file from one system to another, one method was FTP. Another was EDI, where you can send through a socket connection with TCP. HL7, which I talked about, we use that in healthcare. EDI is more in the financial markets, and EDI is also for fulfillment systems and supply chain management and things like that. FTP can, most people are familiar with FTP in IT, but FTP can be used as well to integrate across organizational boundaries. And you can secure a lot of these standards. So FTP has a secure version. EDI and HL7, not so much. You usually have to have a VPN to integrate with things like EDI and HL7. Yet another reason that XML and web services is so much more powerful, because it already has encryption and security kind of baked into the standard. So we can much more easily integrate across organizational boundaries with things like SOAP and REST. So some system inputs. So your primary objective is error-free input. Use electronic devices wherever possible, and avoid human involvement as much as possible. So again, I work in healthcare. I work actually in the radiology market, and in the radiology market, one of the concepts that we have is that when a patient comes in to get an X-ray, the information about that patient is entered into some kind of information system. And when the patient then goes to an exam room to get that X-ray done, we don't want an X-ray technician to have to enter that same information into the machine that does the X-ray. So we want that machine to get that data directly from the system where it was input by the registration people at the front desk. So one time a human puts it in, and then after that, we don't want humans to have to change that information. We want it to kind of flow through the entire workflow. And, as you can probably imagine, those X-ray systems, the machines that do the X-rays, they're not designed to do that really. So they don't support a lot of different standards. So a lot of times we have to do data brokering to support that type of thing. If information is already available in electronic form, use it instead of re-entering, which is what I just described. Validate and correct information at the time and location entered. So some device examples: magnetic card strip readers. So, another great example, every time I go to the doctor's office, I have to, give them all of my information, right? I have to give them my name, my date of birth, my sex, my address. I have to give them my insurance card, and they have to type all that stuff in. But all of those cards have a magnetic card stripe on the back, and there's nothing to stop them from just swiping the card to get a lot of that information. So why don't they do that? I don't know. But you would think that would be a lot more efficient, and it would be way more accurate because the information would be correct. So that's certainly an option. Barcode readers. So again, I work in hospitals, and we use barcode readers a lot to, so people don't have to enter information. Instead, they use barcodes. So even if we print out a piece of paper, there'll be a barcode with the identifier for the patient and their records and all that stuff, so it can be scanned. You have optical character recognition, which can take a document and it can read the characters off that document. That's usually a little bit more expensive, and it's not always completely accurate. RFID tags, which is all the rage now. We've got RFIDs everywhere. Touch screens, electronic pens, digitizers, speech recognition. These are all examples of electronic inputs. So let's also talk about outputs. So we've got system outputs. These could be reports. Reports that can contain specific information on business transactions. You can have summary reports, which are reports that summarize detail or recap periodic activity. Exception reports, which are reports that provide details or summary information about transactions or operating results that fall outside predefined normal range of values, usually good for auditing. And executive reports, which are good for making decisions, right? So it's the decision support systems and things like that. Reports are used by high-level managers to assess overall organizational health and performance. So internal reports are reports or other outputs produced for use within the organization. And then, so types of internal reports. You have external outputs, which are reports or other outputs produced for use of people outside the organization, which would be statements, notices, stockholder reports, things like that. Higher quality, usually more. They might have color. They have to reflect the image of the organization. Going back to my healthcare, my radiology experience, when we, whenever I work with a customer, a lot of times they don't really care about the formatting of these internal outputs. So anything that's being produced internally, plain text is fine. They don't really care. But when it's an external output, they get very persnickety about the formatting. So, for example, if you go get an X-ray at a hospital or an imaging center, the only thing that your doctor is going to see about that imaging center or about that hospital is the report that they get back that tells them about your X-ray. So since that's the only thing they see, they consider that report to be their only form of marketing. So they're very, very particular about that external output. It has to have their header on it. It has to be formatted a certain way. They want it to look pretty. They want it to have their picture on it, all kinds of things. But internal stuff, they generally don't care. It's, it doesn't matter as long as it's readable. Fixed width fonts are fine. They don't need bold and italicized and all that stuff. Turnaround documents, external outputs that includes one or more parts intended to be returned with new data or information is a turnaround. So things like bills. When people send their bill back, they may also be sending back some kind of a form. So here's an example of a shopping cart order from our RMO example. And here's an example of an internal report. So the first one would be perhaps an external output. And the second example might be an internal output. And then here's maybe something for a stockholder. So here's a quick summary of everything that we've talked about. So you can certainly take a minute and look at the summary. And if you have any questions, please let me know. And the next unit, we'll start talking about design modeling.